Hi everyone, welcome back to another devlog update on Kwyll, the retro game creator. I'm afraid I'm a day late today. I normally try and get these out on a Sunday, but had some other things to take care of yesterday, so here we are. This one will be a return to the more traditional devlog style, as opposed to the more tutorial one that I did last time. There will be a little bit more hands-on changes. I'm trying to do a little bit more demonstration of new features rather than just explanation of new features. I feel that's probably a little bit more interesting to those watching. So this update to Kwyll has been mostly around nodes and the logic again. So I'll dive into the logic editor and I'll show you the differences by actually making some changes rather than just explaining what the differences are. This time my development, or the changes that I've been implementing, are driven by my plan to make something more interesting than the test games that I've had up until now. So you'll see what I'm doing in terms of changes, and they're largely around supporting the idea of creating that simple game style. So at the end of this, what we'll hopefully have is 2 game style demonstrators, neither of them particularly finished, neither of them particularly complete, but certainly demonstrating the capability of the system to build different types of games. So without further ado, let's switch to the current status. I'll load up let's load up the platformer game first, because that's got some logic changes in that are most relevant. So if we look at the player, one of the things I changed, which will have very little impact but just tidies things up a little bit, and I felt it was an important thing to do, is you'll see now there's 2 set variable nodes. One which is just for setting things on the object that you're coding on, so it doesn't have a reference, it doesn't have any other information on there. It's just very simple. It gives you a list of the variables that are on the current object, and you set the variable. So that'll be the one that you'll use most. It's much more straightforward. And then there's the other one, which we always had before, and it's used for things like setting object variables on other objects. So this one could potentially be replaced, or should be replaced, with the standard one, but it hasn't at this point. But this one allows you to set things on other objects, so just a little bit bigger and a little bit more complicated. But the most important change here, so this is this section here is the jump logic, and this is significantly, although it still looks fairly complex, it's significantly simpler than it used to be, thanks to the inclusion of one new node, this node, the increment node. So what we'd normally have to have done in the past to be able to increment a variable or change the value of a variable by a fixed amount or a particular amount would be to do effectively a get, followed by a math to do the add, followed by a set. So you'd have to connect all of these together. Those would be your 3. So you'd have the value of dir, you add 1 to it, and then put it back into dir again. So those would be the 3 nodes you'd have, and they were spread throughout various parts in the demo projects. Now those 3 can all be replaced by this one single node, so it just keeps things a little bit simpler. It also does make a noticeable difference in the conciseness of the code that's exported to the specu, which obviously is a benefit. Anything that can keep the size down is valuable. So those are the 2 main things in here. I think you've all seen this one, so I'll just quickly show, but it all continues to work as normal. The simple platform controller works fine, collision and everything, and the various jumping mechanics all work with the new nodes. So yeah, that's set node and increment. They were mainly just convenience features. They weren't adding anything new that we couldn't already do, just making it a little bit easier to do things that you have to do a lot of, and in doing so keeping some of these node graphs a little bit more manageable. So if we load up the other project, which is, or used to be, the simple one that we'll have all seen with the manic miner style character but walking around in an overhead view style. So first things I've done is I've changed the sprites, so now you've got these nice much more RPG style simple character sprites that I drew. I'm no artist, so apologies for the quality, but that's what they are. And if we go to the animation on the player, now you can see he's got instead of just the left and right animation frames, animation settings, he's got left, right, up, down, and idle. And the logic has been updated accordingly. So this is where I want to try and show you a little bit of in a little bit more detail with some demonstration how I've changed a number of different nodes to improve how efficient these node graphs can be. So this particular section here, all of these, all that's doing is setting the direction variable to 1, 2, 3 or 4 based on the input from the controller, and that value is then used down here to set the animation. So if the direction is 0, then it uses the idle animation, otherwise it puts the direction value -1 into the animation, so selecting the animation. Now it bothered me that this was so complex to do such a simple thing. So two things I did. Firstly, I've changed the controller input node, which you'll see. Before, this was a much simpler node. It just had left, right, up, down, jump and fire with output ports. These values here weren't available. Now the reason for that is another improvement over here. So you'll see when you're bringing in values from here, these are the default values that would normally have come in from the controller. 1 if the button is pressed, 0 if the button is not pressed. And then in order to turn these into a direction in horizontal and vertical axes, we multiply left by -1, right by 1, and then add them. The add is to cancel them out. So if both left and right are pressed, they cancel out and you end up with 0. So you just don't move if you press left and right at the same time. And similarly for the vertical, up and down, and then they cancel out through the add. Now these 4 multiplies here seemed a little bit redundant, so what I've done is I've modified the controller input so that it allows you to specify what the positive value is. So when the button is pressed, when the button is not pressed, it'll always return 0 still, because that's false. But when the button is pressed, it can return any value in here, depending on how you want to use it later on in the graph. So what we can do now is set this, instead of multiplying by 1 by -1 to get -1, I can just set that to -1, eliminate the math node altogether and connect that straight through to the add. And similarly here, right becomes 1, that's no longer needed, so that can go straight through. Up becomes -1, and down is 1. So we just basically eliminate 4 nodes and 4 operations in the exported code, just by making this a little bit more configurable. And then the other thing I've added, so I tried to find a way of making it possible to get this in its new form to be able to create the direction variable, but I couldn't come up with a way that did it that didn't overcomplicate that single node. So what I did instead was I've introduced a new node. So if we just unhook all of this, this basically results in a if the left button is pressed, set it to 2, else if the right button is pressed, set it to 1, and so on. So it's just a really complex if-else statement. So if we move those out of the way, and we get our other new node, which is direction. Now this is basically a mapping node. So what it'll do is it'll take the input values from the controller or from wherever you want them to come from. It's basically mapping true and false for left, right, up and down to any particular single value, and then all we need to do is just take the output from that straight into the direction. Now what this does is it'll scan through each of the inputs and choose the first one that's positive and put that into the value, and if none of them are, then it leaves it at 0. Now you'll see this vertical priority here, and this is because it specifically at the moment, I'm not sure if it's going to stay this way, but at the moment it specifically only works for generating direction values for left, right, up and down. There's no diagonals in there. So if you are moving diagonally, or if the up and the right buttons are pressed at the same time, for example, it'll need to choose which to go with if you're doing left and up. So what I've done is given each axis a priority. So by default it's horizontal priority, which means if you're pushing left and up, it'll report left. And that means when you're moving a character around, if you're moving up and down, it'll show the up and down animations. If you're moving it left and right, it'll show the left and right animations. But if you're moving diagonally, it'll show the one with priority, which in this case is horizontal. Now, because of the way that I've set up the animations on this particular character, and I have no way of reordering them yet, I've got to change the numbers here so they don't make, it makes a little bit strange sense, but that's just because I've got left and right and up and down wrong in the animation here. So that's all. So that's basically all of that is now boiled down to a single node, and we can just get rid of all of those altogether. It doesn't unfortunately make a huge difference in the export to the Spectrum side of things, because it still needs to do all of the checking, but it does give some optimization potential, and I've got some ideas for making it more efficient on the Spectrum side in the future. But it does certainly make working within the logic editor a lot more cleaner. And hopefully, if everything works according to plan, we should see the new game with left, right, up, down animation. And as I say, if I go diagonally, it'll prioritize the left and right, but if you're just going up and down, it'll use the up and down animations. So that's the logic side. The other things that have changed, the eagle-eyed amongst you may have noticed some new buttons over here, and this was a needs must change. I got fed up of drawing these animations by hand and realised that obviously the left and right are mirrors of each other. So I've introduced these two new buttons to flip in vertical and horizontal directions. Now these three buttons up here are mode changes. They change the way that you work within the grid, so paint, mask or move. These are not, these are just immediate actions. So if you choose a sprite and you click that, it just flips it immediately, and similarly vertically as well. So that's just convenience for making mirror images of different sprites and so on. That was quite useful when I was drawing these sprites. The other thing that's changed, and this was something that was kind of requested on the forums before the Discord channel came along. Someone asked about the system I had before of moving between rooms on the map. Now if you recall, what I had was a certain object type, this one here, the portal, which I placed here so that when you collided with it, so I could drag one over and show you what I mean. So if I placed it, for instance, there, I could add some logic to the player that checked to see if it collided with that sort of object and moved to the right room, and the object has a room number associated with it. So I always thought that was a little bit clunky, and I wasn't over the moon about it, but it did give a little bit more flexibility, so I was very keen to keep the capability to do that. But I've decided that now it makes more sense, I think, to be able to have, as we have the map where you place rooms alongside one another in in this global space, that the system should be able to determine with reasonable accuracy where you mean to go when you move out of one room, if there's a neighbouring room. So that's what I've done. I've implemented that. It's a early implementation now. It only works for the global object for the player, and it's forced. So there's no way of having an object that goes off screen and doesn't, a global object that goes off screen and doesn't switch rooms. But ideally what I'll have is some way of either marking a particular object as the player or as an object that enforces room transitions when you go off screen. But for now, basically, if I go to the rooms, we're going to need to add some more rooms. So I'll do that by duplicating the existing room, rename it to, and then we'll get rid of some of the stuff we don't need. So we'll get rid of the house, I think. So if I switch that and get rid of the collision layer first, and then we'll get rid of the tiles. And this is where you can see the importance of the attribute markers here. So we wouldn't have known that there were attributes being exported there, which would waste memory on the Spectrum side because they're just not needed. So now we can switch to paint mode and just get rid of those attribute changes as well. So it gets rid of the house altogether. And then we need to close these two off over here. So we'll draw some new sprites in there, colour them, and add collision so you can't get out through there. And down here the same. Paint and collision. And then for this room we're going to want to put this one, let's make this one go out here. So basically it's 3 wall blocks up and then there's a 4 high doorway. So over here what we actually want is we're gonna place it like that. So actually the door to this new room will be at the top. So we want it up here and we want 3 blocks, 3 walls, and then 4 spaces, and then we'll clear the collision detection and the attributes on that one. So now we've got that new room, we should be able to go to the map, drag our room in and place it so that it's properly aligned. And while we're here we'll duplicate that room. We'll call that one room 3. And then all we need to do on this one is first of all fill those back in again. Green, so we can just see, yeah. And then down here, if I remember rightly, this room, because we're coming down here, has just 1 block. So if we go back to room 3, and we're coming in from the top, so we'll delete 1, 2, 3, 4. Turn off the collision on those 4, and that should be good. Have I done that right way around? I think I've done it the wrong way around. Yes, I have. So this is where undo comes in handy, hopefully, if it works. It's not going to work. Okay, we'll draw it in by hand and I'll investigate why undo didn't work there. And paint it back again. So what I should have done was open that hole up down there and turn that off. So now if we go back to our map, we should be able to bring this room in and place it where we want. Now, even though I'm not putting anything in terms of portals or collision objects or so on, if everything works according to plan, it should detect when you go off screen and that there's another room in the map and take you to the right room. So that just happens all automatically now without any additional setup, which makes things a lot easier. And all you have to do now is in the map screen lay out your rooms correctly, and that will just all take care of itself. So if for example, if I'd made these rooms a little bit more sensibly, so that this one was too lower and this one was too higher, so moving the doorways, then I could have put a portal or an opening in here that would allow you to go through there. Perhaps that's for another demo. But that's basically all of the new features as of this current status. I'll be releasing a new version out to the alpha testers on Discord, so keep your eyes open on that, and please do hit the subscribe button if you like what you're seeing, and leave a comment, and I'll see you next time.